Okay, so we're going to do some revision on transformations. So there's 6 that you have to automate, but 4 main ones, and then the reflections are kind of a special case of a stretch. So let's just do the translations to begin with. So translations, you can spot if there's a translation if there's been a plus or minus if I've added or taken away something. So if my original curve is y equals f of x, and I have f of x plus k, the rule is if it's inside the bracket, then we do the opposite to x. So it's a translation, and we take away k from x. So it's that. Yeah, sketch some graphs so you can see what I mean. So maybe just try something simple like y equals x squared and y equals x plus 1 squared, and see that it's moved to the left by 1. If the k was on the outside, then we translate, and since it's on the outside, it's y, and we just do what it says. So we translate it up by k, and again, try y equals x squared and y equals x squared plus 1, and see that the graph just went up by 1. Now, if that was a minus, that would turn to a plus, and if that was a minus, that would change to a minus. Yeah, you realize by now, hopefully, that taken away number is the same as adding a negative number. Okay, and the kind of trickiest things you can get with these are stuff with maybe asymptotes. So you might get y equals 4 plus 3 over x minus 1. And they might ask you either to sketch it or find the asymptotes. Well, if we start off by thinking of f of x as just 1 over x, then we know the asymptotes are x equals 0, y equals 0. Nice and simple. And if we try and write y in terms of f of x, well, it's f of x minus 2. So I take away 2 from the x. Look, there's invisible brackets on the fraction. I times that by 3, because that's the same thing as 4 plus 3 times 1 over x minus 2, isn't it? And then I'm adding 4. Yeah, because that plus 4 I can just put at the end. So that's a translate 2 to the right, stretch by 3, which won't affect my asymptotes. And then this means go up by 4. So my asymptotes becomes, well, if I go along 2 on the x, I get x equals 2. So if I go up by 4, I get y equals 4. Yeah, simple as that. Yeah, otherwise you can try and spot it just from looking at here. If you substitute 2 into there, you're going to get 0, which you can't happen. So that's why x equals 2 is an asymptote, and 4 is an asymptote because this fraction can never be 0. 3 divided by a number will never give me 0. Okay, another thing I like to ask with these translation ones is I like to give you a curve. Let's just do one I've written down: x cubed minus 2x squared minus 5x plus 6. Then in the first part, I might get you to sketch it. They might get you to use the factor theorem, the polynomial division to work out what the roots are. So I'll just give you the roots. So we get 1, minus 2, and 3. They might then say in part B, give you a new graph, y equals x minus 5 cubed, take away 2 lots of x minus 5 squared, take away 5 lots of x minus 5 plus 6. And they might ask, what's the root of that equation? Now it'll only be 1 mark, 2 maximum. So they don't want you to expand all this and then work it out. Equally, you could type in your graph and solve it, but then they could just use algebra instead. So it's really important you understand the method. So if we call the original one f of x, hopefully you're going to agree that this thing here that y equals f of x minus 5. Yeah, not too tricky. And so that means it's been translated to the right by 5. So all these roots go to the right by 5. So I get 1 add 5, which is 6, minus 2 add 5, which is 3, and 3 add 5, which is 8. Yeah, so there's my new roots, 6, 3, and 8. Yeah, minus 5 means to the right by 5. Or we could think of it as x minus 5 equals 1 plus 1 to get what x is. They could also ask you as a part B, they could, can I do this? Yeah. They could, instead of giving you a number, they could give you algebra, like I said. And what they could say is this crosses the origin. Okay, so they might say find a. So again, if you look at this and look at this, hopefully it's not too tricky to spot that it's just a transformation of x minus a. So that means it went to the right by a. So my 3 roots this time should be 1 plus a, minus 2 plus a, and 3 plus a. Now, if we know it crosses the origin, then one of these should be 0. So either that's 0, because remember, if something crosses the origin, there's a, that doesn't cross the origin, that's a bit better, then that means one of the roots is 0. So we get a is minus 1, a is 2, or a is minus 3. And that could work with anything. If it says it crosses the x-axis at 7, you do the same thing, but it would be equal to 7, not 0. Okay, next transformation, or type of transformation, are stretches. So we have, again, if we have y equals f of x, we could have y equals f of ax. So it's inside the bracket, so it's in stretch the x direction. Or you could call that parallel to the x-axis. And the scale factor, well, it's the opposite. So it's not a, it's 1 over a, it's the reciprocal. If we have the a on the outside, it's the same thing, but it's a stretch in the y direction. You can just put x, and the scale factor stays the same, stays as an a. Now, these could be fractions, it could be a half and a half, for example. And then if that was a half, scale factor would be 2. If that was a half, scale factor would still be a half. So try it out. You could try the graph sine of 2x and draw the graph 2 sine x and compare it with the sine graph, and you should be able to see the stretches. Okay, now the 2 special cases of these are when we get reflections. So y equals f of minus x, and y equals minus f of x. Okay, well, it's inside the bracket, so that means the x changes. Yeah, so this x will go over here. So that's a reflection in the y-axis. Yeah, but I'm just going to write it instead of the y-axis, I'm going to call it x equals 0, just so you can see the link. Inside the bracket, it's still to do with x. And same here, if it's negative, it's outside, so it's y that changes. So it's go from here to here, or here to here, for example. So it's a reflection in the x-axis. I'm just going to call the x-axis y equals 0. Okay, and 2 more things I want to do. I just want to look at how can we write stuff in the function form. So if I give us 2 functions, let's have something simple as x squared and g of x could be 4x squared. Let's just stick with 4x squared to begin with. So if we would do this, then actually I'm going to stick a +1 at the end. If we look at this, the first thing you check is there any kind of translation? So are there any plus or minuses? Well, I haven't added anything to x, it's definitely times, and haven't added anything to the end of it either. So it's not a translation. So it's going to be stretched, so it's definitely being times. So you might think straight away, oh, scale factor 4. But if you see, not the whole thing's being times by 4, it's just the x. So I would take a guess that the function is, I'm going to call it a, it's f of x. Yeah, the x is being times by something. So if I sub that into here, I get a squared, x squared, when I square up, +1. So I want a squared to equal 4. So a must equal 2. Yeah, I guess you could have -2 as well. Yes, yeah, so that's how we do those ones. So then you would say that g of x is f of 2x. So to stretch, x direction, scale factor of half. Okay. Let's try something like f of x is 4x add 5, let's say, and g of x can be 4x minus 2. So hopefully you can see that definite times because the 4 stayed the same. So it must be a plus or minus, so it's a translation. So if it's a translation, then we need to check is it the x or the y that's changed. Well, to be fair, this one could be either, but it's probably easy to think of the y changing. So we think that g of x looks like f of x plus k. So if I sub that in, I get 4x add 5, that's my f of x, plus k, but I want this bit to equal -2. So I want 5 add k to equal -2, so k must equal -7. So g of x is f of x -7. So that means it's translation with the vector 0, -7, so went down by 7. Okay, and let's have a go at doing, let's do something like f of x equals, let's try and do 2 and 1. Pause a second till I think it's added. So my original function is 3x at 5, and my new function is 6x add 11. So hopefully you agree that there's definitely some kind of stretch, because that's changed from a 3 to a 6. And it looks like it's some kind of translation as well, because I can't do 5 times 3. Well, 3 times 2 would give me 6, but 5 times 2 wouldn't give me 11. So it looks like there's also translation. So there's two things, the stretch and the translation. Now, this could be more than one answer. So I'm going to show you one possible thing. I could, first of all, if I times this by 2, that gets me 6x add 10. Then if I add a 1 to that, I get 6x add 11. So this could be f dot 2 f of x add 11. Good. And Actually, I think I'm going to leave it there because I think that's probably the easiest way to think about this, is just to think of it as times that by 2 and then add 1. But if you didn't want to think of it another way, I can't make my mind up. Yeah, let's do it. Then I could, first of all, just times the x by 2 to get 6x and 5. And then I could add 6 to that to get that 11 on the end. So I could also write that as f of 2x at 6. So there's sometimes more than one way of writing transformations. So here, it's a stretch in the y direction by 2, then I add 11. Here, it's a stretch in the x direction by 1/2, then add 6, then translate by 6. Sorry. Okay, and the last thing is, this is probably the easiest bit. If I give you a curve, y equals f of x, and I give you a point on that curve, let's say 4 minus 8, the exam question could ask you to write down the coordinates and the different transformations. So let's do f of x add 1. So that means the x changes, it's inside bracket. I do the opposite, so I take away 1. So the coordinate would be 3 minus 8. If I had minus f of x, so it's outside the bracket, so the y changes. So that means the x stays the same. And times by minus 1 to get 8. Let's have f of 2x, and also let's stick a plus 5 at the end, just for the fun of it. So the x is going to change, and I'm going to times by 1/2. So 4 times 1/2 is 2. And since it's on the outside, the y is going to change, and I'm going to keep the same, so I'm going to add 5. So minus 8, add 5 is minus 3. Yeah, so I think this is a bit easier than the transformations, but you need to sit and remember those 6 rules. The 2 rules for translations, 2 rules for reflections, and 2 rules for stretches. Yeah, so have a go at the practice questions, and what we'll do tomorrow is we'll look at a new transformation using the modulus function.